Okay, so for all of you who have joined in between, who have done few units, some of you who have done the entire 13 units, just for you guys to be aware, we are starting the unit 12, which is about polar coordinates and graphing polar coordinates. After that, we'll have conic sections, so that will complete one iteration of pre-calculus. But for you guys, it doesn't really matter, because I don't think there's anybody in the class who has gone through the entire 13 units. So basically, after we complete the 13th unit, we'll go back to the first unit and then repeat this cycle, so that everybody gets enough chance and time to go through the entire syllabus. Alright? So holistically, if you want to get a sense of how long it's going to take for us to do one fresh iteration, I've seen it taking close to 6 to 8 months actually. So when we start the second iteration, you can be rest assured that before you complete this school year, you will go through the whole iteration one more time. So like Praneeth and Vishal, they have joined recently, so they have just seen me for a few classes. Likewise, Tanvi also has been here for little more than a month. So, and same with Davik and Arush also, I think 2.5 months, right? In pre-calculus? Yeah. So nobody has seen other units, so you'll get to see those units, and then if there is some topic, some concept that you guys want to cover ahead of time, just let me know. Okay, I have some students in the class without the tuition fee who are distracting me right now. Mosquitoes, not mosquitoes, some ants and flies. Okay, alright.
Turn off the mic.
It might help with that. There is a switch here. You are tall enough to switch off. This one.
Alright.
Okay, so we are starting with this unit called polar coordinates. Can everybody see the board okay? The full board? Okay. So now the question is, what is polar coordinates? Everybody here, Arush, Davik here. So what is a polar coordinate? We have broken our head enough with something called coordinates or the coordinate plane, the x and y axis. Yeah. And now everybody must be thinking, from where this new thing is coming into play, and why do we even need that? So if you look at these coordinates, the x-axis and y-axis, these are called regular coordinate plane, or you call them Cartesian coordinates or rectangular coordinates, depending on whatever you guys are comfortable with. Is everybody okay with whatever I said? Or you have a fourth name that you are aware of? Cartesian coordinates or rectangular coordinates, or just a coordinate plane? Now, this part is fine. Let's look at a little bit differently. Now, if I look at, let's say, a point here, let's say P, you will say, okay, what is the x and y coordinates? You will say, this length is my x coordinate and this length is my y coordinate value. So this will be x comma y. Yep, this point's coordinates will be x comma y. Okay. How about representing this differently? Meaning, from this origin, let me join this point and say this length is r. I will say this is r. And this line, this point, which is joined with the origin, makes an angle theta with the x-axis. I will say, okay, fine. This point P has coordinates such as the length r and the angle theta that it makes with the horizontal axis. This is pretty much in line with what we have learned about vectors, if you guys remember this. But let's not mix it. What I'm saying is, this point P, if I represent that in Cartesian coordinates or rectangular coordinates, I'll say x comma y. X is this distance, y is this distance. But instead of that, we are representing this as the distance from the origin as r and the angle theta that this line makes with the positive x-axis. So r comma theta, this is called the polar coordinates. Now $1 million question, I mean nobody gets $1 million though, is why do we even need these extra coordinates? What is the value that it is, what is the purpose that it fulfills? Any thoughts? Any weird thought, any creative point of view? Praneeth, Tanvi, Vishal, anybody? Why do we need this something called polar coordinates? I mean, why do we need to represent the same point in 5 different ways unless we are convinced about the value that it brings to the table? Any thoughts? Anything creative, interesting? Vishal, Praneeth, Tanvi? No creativity? Okay. Vishal, any thoughts? Don't give up. Tanvi, any thoughts, beta? Okay. Now let me go to the next level. Let's say if you look at a coordinate plane, basically from here all the way till here, how many degrees we are talking about? 360 degrees? First quadrant, second quadrant, third quadrant, fourth quadrant, all put together makes 360 degrees. Or in radian, if you talk about it, you will say 2 pi. This is the maximum angle that we are talking about. What if somebody says a point P is reached after making 2 pi plus theta, or 6 pi plus theta. We are not trying to limit ourselves to that constraint of 360 degree. And this is something that is more prevalent when you guys start working on your career plans, which is more around universe, space science, right? I mean, that is where you will see the more interesting dimensions that will come across. If you are talking about, let's say, I'm just giving a vague example. This is Sun, and this is one planet that is revolving around the Sun. And if you have to represent the cyclic motion or position of a planet after, I mean, I'm assuming this orbit is circular in nature, which is not the case though, but I'm just giving an example. If you have to find out after 20 days what is the position of this planet around Sun, 20 days and 6 hours, then if it makes one rotation around this in 2 days, let's say, you're talking about 10 rotations and then 6 hours somewhere here. So basically when you're talking about angles which are more than 360 degree, okay, let's not try to overwhelm ourselves by thinking too much about the practical application of it, but there's no limitation, right? I mean, when we started trigonometry, we said, okay, theta from 0 to 90, but then are we limiting theta to 90 degree? No. That is when the unit circle concept came into the picture. Same way, this polar concept or polar coordinates actually help us to deal with angles when we go beyond 360 degree. So 360 degree is anyways covered, beyond that is also covered. That is why we talk about polar coordinates. Are you guys finding it relatable, or I'm still talking about a hypothetical concept right now? Vishal, relatable? Tanvi? Will you guys be able to give a narration of this story to somebody when somebody says, okay, why why the heck you are even learning polar coordinates? I mean, you already know Cartesian coordinates, rectangular coordinates, or no, you guys are expert in coordinate plane. Why do you have to even bother about polar coordinates? So this is the answer or justification for that. Okay. Now, so far we have been able to convince ourselves why do we need to even worry about learning a new concept called polar coordinates. Yep. So now look at this. Is this something that is unrealistic or hypothetical? No. It's just a different representation. Same content with a different packaging. We are essentially talking about the same point. When you look at Cartesian coordinates, you are looking at the x value, x coordinate value and the y coordinate value. That is how you are representing it. In place of x and y, you are representing this as r, the whole distance between the origin and this point, and the angle theta that it makes with the positive side of x-axis. Now, if you want to draw a relationship between these two, what will this r be? This is your concept from Pythagorean theorem. This is a right angle triangle, and this x squared plus y squared will be r squared. So this r, the distance from origin to this point, is nothing but the square root of x squared plus y squared, or square root of the sum of squares, square root of sum of squares of the x and y coordinate value. Yeah. So this is the r part. So if you know the Cartesian coordinates, you can find out the r. How about the theta part? How do you derive the theta? If you, let's say I tell you that, okay, I have Cartesian coordinate 3, 4 for a point. Can you find out the polar coordinates? You will say to find. I will find out r. R is nothing but this square plus this square root. So 3 square is 9 plus 4 square is 16. So 9 plus 16, 25, square root of that will give me a 5. You found r. How about the theta? Vishal, Puneet, Arush, David, Tanvi. Not Tanvi, Tanvi, right? That's how I should pronounce it, correct?
Yes, sir.
Okay. So I have a child named Thanu. So that's how I got little carried away and called you Tanvi, but sorry about that. Okay. So here we got r. R is fine. How about the theta? Meaning, what is the angle that point makes with the x-axis, positive of x-axis? How do you find that out?
Can I say something else quickly?
Yeah. No. How will you find out? Give me the approach. Calculation I'll let you do with the calculator.
I need to figure out if I'm thinking what I'm thinking instead of what I'm actually thinking.
Tell me what you're thinking. I'm more interested in that.
I'm trying to see. I was trying to search up the sign negative, like
Inverse,
sign negative one.
odd
Yeah.
sign.
I was trying to see if you're supposed to do that. Yeah.
See, math is the most realistic subject in our life. That's why, I am not saying that I cannot teach other subjects. I have studied other subjects also to pass all my exams and come to this stage. But why maths got stuck with me is because I'm still finding that relevant at this age. Now, what I mean by that is, anything and everything that you know, you can relate. Now, if you have a theta here, and you have dropped a perpendicular, right? If you look at this OP and let's say this is Q, this is nothing but a right angle triangle. This is your SOHCAHTOA's base. Yeah? Trigonometry's base. So here, this distance is nothing but y. This is your P, x, y is your y coordinate, and this is your x coordinate. This is your y value, this is your x value. This distance is x, this distance is y. Now, if this is your theta, which you are trying to find out, this is the tan theta will be equal to this divided by this. SOHCAHTOA. We are talking about TOA. So, tangent is opposite side divided by adjacent side. side apply to the theta, y over the adjacent side. That means theta would be equal to, you can call it tan inverse y over x. If that gets confusing, you can always say arc tan of y over x. And you put arc tan in your calculator, it tells you, if you know the value of y and x and try finding out arc tan, it tells you what the value of theta would be in degree or radian, whatever it is. Is that making sense or no? Tanvi, Vishal, and trust me guys, you don't have any compulsion for saying yes if you have tiniest of doubt in your mind. I am such a boring guy, I can explain the same thing 5 more times. Yeah? Vishal? Okay. So I am assuming that this concept is relatable, at least you guys are not finding it something coming out of the blue. In a nutshell, if somebody says, what is a polar coordinate? Polar coordinate is nothing but a different representation of Cartesian coordinate in a polar form, where you don't look at x and y coordinate value, you look at the distance of that point from the origin and the angle that it makes with the x-axis. And then when you look at it, this is the relationship. If you know the Cartesian coordinate, you can find out the distance r, and you can also find out the angle that it makes with the x-axis, relating that with the basic trigonometry concepts. Yeah? Everybody with me? And the other justification that I tried my best to give you guys was, why do we need to even bother about polar coordinates? That is primarily because when you are looking at Cartesian coordinates, we are limited to the angle of 360 degree at the most. First quadrant up to 90 degrees, second quadrant if you consider, you are going up to 180 degrees or pi radians. If you include third quadrant as well, you are going up to 270 degrees, and fourth quadrant 360 degrees, and your world ends there. If you want to consider going beyond 360 degrees, or when you are talking about cyclic motion and applying trigonometry concepts, meaning you are going to go beyond 360 degrees or 2 pi, the sky is the limit. That's where polar coordinates help you. Everybody okay? Now let's look at some practical relatable problems, and then only this concept that we have, the concept that we have learned so far will probably make a bit of sense. Let's look at it. And I know it's getting dark, but hoping you guys are still able to see the board, okay? Kani, Tanvi and Vishal. Yeah? Okay. Now, other thing that we talked about, that if you have the Cartesian coordinate, you can find out the polar coordinates. Or applying the Pythagorean theorem, and theta applying the basic trigonometry concepts also cut over. Yeah, Arush? Convinced? No concerns? Okay. Now, so if you have the, let's say this, let me do a little bit of more drilling into it. So if I have, let's say, I'll give a different name. If I have the Cartesian coordinates as x comma y, polar coordinates r and theta for the same point, we saw that, okay, if I know x and y, I can find out this. Is the reverse of that also correct? If you have the polar coordinates, would you be able to find out the Cartesian coordinates out of it?
I don't think so.
I don't think so. So take don't out, and it will be good. And again, see, this is where getting your hands dirty is very, very important. Whenever I ask you a question, okay, I might be in a very bad frame of mind that day because I did not have breakfast and lunch and I'm out of my mind. Regardless, whether I'm asking a good question or bad question, do that scratch work. Okay, this is the point where x and y, look at this, okay? do as much scratch work as you want to do. This is X, this is Y, okay? Now, what is my R? Is this one. So if I know this R, I know this part, okay? Right now I'm aware of R and the theta. So I know this theta. Okay. What I don't know is Y. And what I don't know is the X. Okay. But this and this I know. Can I relate X and Y in terms of R and theta? Why not? Trigonometry gives us the basic rule of thumb.
That you were talking about just from R.
Yeah. You have only R and theta known to
No,
you.
like only R.
No, I'm saying whenever I say polar coordinates, I will give you R and theta both.
No, I didn't think you were, I thought you were pointing at only R, so I said I was.
No. So polar coordinates, see again, if I just give you R, if I'm giving you only R, I'm only giving you the absolute distance from origin. So this R, if I'm just giving you R, then I'm trying my best to get you confused. This R is the same value everywhere. Any point on the perimeter of the circle. Not circumference of the circle. So if I just give you R, then my question doesn't hold water. That is a wrong question, because I'm not giving you any coordinate plane. If I'm talking about, regardless whether we are going with Cartesian coordinates or polar coordinates or any other form, let's say tomorrow something evolves. Our goal is to locate that point in the most absolute, accurate way. If you guys are coming to class and you only know 5 miles from your home, you can land anywhere. That might, wherever you end up being, that guy might be a sociology teacher actually. You were looking for math class. So, jokes apart, what I'm saying is, if I'm just giving the R, I'm not giving you a focused way to find out and locate that point. I have to give you the theta. Okay? So, if you have theta and R both, now you guys know Y over R. Y over R. This Y over R is nothing but sine theta. That means Y equals R times sine theta. X over R is nothing but cos theta. So X equals R times cos theta. So essentially what came out from our discussion is, if you have Cartesian coordinates, you can find out the polar coordinates. If you have the polar coordinates, you can derive your Cartesian coordinates as well. Does that sound okay to everybody? Arush, Davik, Tanvi, Vishal, Praneeth, everybody?
Yeah.
Okay. So my only request, recommendation or preaching that I keep on doing, right? And when people get old, they start doing more preaching. So I'm getting there almost. So what I keep preaching is that if you have a problem to solve, don't be hesitant to do that scratch work. When you draw, whatever is coming to you as a question, if you do the scratch work, try collecting the points, put it on a paper, try creating some visual out of it. You will see that many a times it decodes the problem for you. Yeah? Okay. Okay? You're looking very sad. Huh? Are you okay? Yeah. Okay. I don't know how many hours I smile in a day, but when I'm teaching math, you will see maximum smile on my face because I'm enjoying it. So I want to see the same expression on your faces, even if your video is not turned on. I want to read that expression. So when you say something, I can make out that, okay, is it making sense? Are you guys enjoying it or not? That's my whole goal. Okay. Let's look at some problems. So we have looked at what is a polar coordinate, why do we need polar coordinates, what is the relationship between polar and Cartesian coordinates, how do we relate, how do we derive. Let's look at some legitimate problems and we'll see with whatever we have done so far, are we able to relate that and solve something. So my first question is, I'm reading it for you guys, okay? Just pay attention to what I'm saying. Select all equivalent ways to name the same location as the polar coordinates. It says, select all the equivalent ways, okay? It's not saying one. All the equivalent ways to name the same location as the polar coordinates.
And the polar coordinates given to us are -7. -7,
Comma,
3 pi over 4.
select all the equivalent ways to name the same location as the polar coordinates. This.
So this is a polar coordinate, -7, comma 3 pi over 4.
And then the options given to us are
This. First one is 7, comma -13 pi over 4. Second option is -7,
comma,
-5 pi over 4. Third option is 7, comma minus pi over 4. And fourth option is -7, comma 11 pi over 4.
So I'll read the question for you guys one more time. The question says, select all the equivalent ways to name the same location as the polar coordinate this. This is a polar coordinate. You have to find all the equivalent ways to name the same location the polar coordinates. And the first one is 7, comma -13 pi over 4. Second one is -7, comma -5 pi over 4. Third option is 7, comma minus pi over 4. And the fourth one is -7, comma 11 pi over 4. Essentially, you have been given one polar coordinate and you have been asked to find out all the equivalent polar coordinates from the 4 options. There could be one option, there could be more options as well. It says select all. So I'm giving you guys 2 minutes to think about it. This one is more like a jump start for this topic, okay? So let's see what is. I'll give you guys 2 minutes to read it, think through it, and then we'll talk.
I'm turning on the light because is it okay?
Yeah.
After 2 minutes, I'll start picking your brain. Okay. Tell me what is going on in your mind. How are you thinking about it? Are you guys ready to give me some story or you need a minute more?
A little bit more.
Okay. I'm giving you guys 1 more minute, okay? I'll take a quick nap every time. Anybody ready with the story? Vishal, Praneeth, Tanvi? At least tell me what is going on in your mind, what you're able to think, what you're not able to think. even saying that I did not understand the question at all is also okay. Okay, Tanvi, what is going in your mind, beta?
I think that it can't be the first, it can't be A.
I'm sorry, beta?
I think that like I have never taken A so far. Because,
Okay. No, so I'm more curious to understand how are you approaching this? I mean, when you read this question, what started kind of cooking up in your mind? That's what my focus is right now. Give me some story.
so like we started with -7, 3 pi over 4, and then if we switch to a positive radius, then we get 7, 7 pi over 4.
Uh-huh.
So then we can also write 7, negative pi over 4.
Okay.
I think that yeah, that's all that's been going in my mind, and I think that it also can't be the first option.
Okay. Okay, let's see what Praneeth says. Yeah, Praneeth, go ahead.
So when I looked at this one, I noticed that the R was -7.
Give me a second, beta. Give me a second, okay? Yeah, now tell me.
So I realized the R distance from the origin was -7. So I was trying to figure out how we could get a negative distance, which is kind of
Okay. So here's the thing. So let me decode this for you guys. Okay? Now, first question is, how do we get the negative distance? That's a fair point. But let's say when you do 3 square plus 4 square, that's the two sides, making up your hypotenuse r square. So r square equals 25. R equals square root of 25. You can get R equals plus and minus 5 both. Yeah. So here in this case, okay, the way you will relate is this. I mean, you can leave aside the plus or minus thing, okay, for now, because square root of any number will give you a positive square root as well as negative square root, both, right? So that's why I will probably rule out that thing. What I would want to worry about is this angle. Now look at this. If I am talking about angle of 3 pi over 4, 3 pi over 4, this is pi over 2. Let's convert that into, okay, so this is pi over 2, this is pi, this is 2 pi. 3 pi over 4 is 3/4 of a pi. So you are talking about 135 degree basically.
Yeah.
So this is 3 pi over 4. How many ways you can get here? Look at this. When you're looking at this minus 13 pi over 4, let's break it down. Let's take the pi thing out. So this will be 3 pi plus pi over 4. That is how it becomes 13 pi over 4. Correct? So when you're talking minus 13 pi, so here when you measure an angle negative, you go clockwise. So this is 1 pi, 2 pi, 3 pi, and then pi over 4. You are getting to the same point. Going going clockwise. So this one also getting you to the same place. So this could be a possible answer. Now let's look at this guy. Minus 5 pi over 4. That means minus pi plus pi over 4. Minus. So this is pi and plus pi over 4 here. This is coming here. This one is not the option. So this one you will rule out. this one minus pi over 4, again minus pi over 4 from here, it only comes to this place. This is also ruled out. Now 11 pi over 4 is nothing but 2 pi and 4 2s are 8, 3 pi over plus 3 pi over 4. So 3 pi over 4 after 2 pi. So 1 pi, 2 pi and 3 pi over 4 gets to the same pi. So this one and this one is landing the same place. So ultimately when you look at the angle, what you have to do is, since all these were same numbers with a positive and negative, so you have to, this was not your elimination criteria then you have to look at angle. Which angle helped me get to the same place? Because my magnitude is the same, be it positive or negative. This one helps me get to this point is here. This one gets me to the same place going clockwise. So this one looks to be an option. Minus 5 over 4, minus 5 pi over 4 gets me to this place only. So this is not an option. This point is different from this point. This one minus pi over 4, you are going clockwise, you are stopping here. This point is very different from this point. So ruled out. Then this point 11 pi over 4 is nothing but 2 pi plus 3 pi over 4. So 2 pi, 1 pi, 2 pi and then 3 pi over 4 gets to the same place. So ultimately, for a problem like this, you have to look at two parts. One is a magnitude. Imagine if you had 8 here, 6 here and 9 here. If you are talking about equivalent of a polar coordinate, essentially your magnitude has to match. Your R has to match. If your R is not matching, your whole comparison has gone for a toss. So then it was an easy picking, just this one. But here, in all the cases you had matching magnitude, so that was not part of your elimination criteria. Then you have to look at the angle. How do I calculate the angle to get to the place? What are the angles that is getting me to the same place as this original polar coordinate that I am comparing with? Does it make sense? Vishal, Tanvi, Davik, Arush? Yeah? So net polar coordinates help us navigate to the point knowing that it's like a revolving around the circumference of a circle. You know the radius and hence you have made the circle and you have to figure out which point on the perimeter we are talking about. The only thing that you have to be a little careful about is being very, very clear about what a positive angle versus a negative angle means. When you are going anti-clockwise, that is a positive angle. When you have a negative angle, you move in the opposite direction, meaning clockwise direction. Everybody clear? Okay, let's move on. Let's pick up the next one. So we'll see, we have only 20-25 more minutes. What we will do is, we'll do conceptual debate here, okay? Meaning, look at a problem, give me an approach, okay? I'll not let you guys solve it to the end. Just give me an approach. As long as we are clear about the approach, we should be able to solve it. This question says, select the graph of the polar coordinate 5, 135 degree. It says select the graph of the polar coordinate 5, 135 degree. And you have options. Let me not give you the options. This is the polar coordinate. First point is here. Second point is one, 2, 3, 4, 5. Second point is here. Third point is here. This is 225 degree, 135 degree. This is
45 degree here, and this point is here. This is probably 4. This is 5. This is 2.
And yeah, there are three options you have. Do you think this problem needs to be solved?
No.
Vishal, do you think this problem needs to be solved? I'm saying it says find out the polar, locate the point with this polar coordinates. You have three options, this one, and this one. And this is 1, 2, 3, 4 and 5. So your radius is, R is 5, meaning 5 on the total distance 5, this radius 5. So basically I'm talking about this circle which crosses 5. Okay? And then angle 135 degrees. So this is 90 degrees, 135 is given, right? You have to just pick up the point. You have to just locate it. So that was not even worthy a problem to be looked at, but we just looked at it to get a, what do you call it? It was more like an refreshment than being a problem. Tanveer, Praneeth, Vishal, were you guys okay with what I said or? Okay. Now let's look at the next one. Okay, this is a word problem. There was one more problem that I had sent that you guys can look at it offline. Same thing, we have been given 4, 13 pi over 4. And you have to locate this polar coordinate among the 4 pictures that are given to us. Okay. When you look at this 13 pi over 4, but you see this is a improper fraction, right? So just break it down. It will become 4 3 are 12. So 3 pi plus pi over 4. That helps you locate where we are talking about, which quadrant we are talking about. 3 pi, 1 pi, 2 pi, and the third pi. Then pi over 4. Yeah. So as long as you are able to locate or visualize this one, it will be fairly straightforward. Then you have to only look at the length and the angle. That's it. Now let's look at a difficult looking word problem, or not a word problem actually. I'm talking about converting polar coordinate. Polar coordinate to Cartesian coordinates. And the question is this. It says convert the polar coordinate 5, 5 pi over 7 into regular form or Cartesian coordinates. So you are given the polar coordinates, you have to convert that to Cartesian coordinates. Can you guys try giving it a shot? And if you want to use calculator only for calculation purpose, you can.
What was the question?
So you are given the polar coordinate 5, 5 pi over 7. You have to convert this into or find out the Cartesian coordinate for this or the regular coordinate for this, whatever you call it. Basically x, y. Is that clear, Vishal? Vishal, are you clear with the question now?
Yeah.
Yeah, okay. Give it a shot. Tell me what would be your recommendation for this one. At least give it 2-3 minutes and then tell me your story before we go to the next problem. Tanvi, are you clear with her? At least the question part?
Yeah.
Okay. You sound very low. I want all my kids to be very energetic and happy when they are solving a problem, okay? Give me a very positive vibe at her. Praneeth, try. Okay. Okay. Tell me if anybody is close to being done. I have two more problems that I want you guys to try, because more you try, more comfortable you and I will get. I mean, I have a silver bullet. I can give it to you guys, but it's like memorizing something, which I prefer not to. So that's why I'm not giving that to you guys. I mean, you will eventually end up doing that, but not for now. Yes, Praneeth.
After rounding, I got negative 3.12 as the x coordinate
Okay.
and 3.91 as my y.
Okay, so x is negative value and y is positive value. So you are essentially in the second quadrant.
Second quadrant, that is visible from here. I mean, I should not be even asking that question. Yep. Okay. All right. How about Tanvi and Vishal? You got the same thing? David? Yeah.
I got the tech negative 3. I think I may have done it earlier. Like,
So let me just help you guys do a review of what you have done. So David and Arus, I see you guys are pretty close to being done.
Yeah.
Almost.
I don't think so.
Okay. See, simple. This is how it will start. And I know I'm not as intelligent as you guys are, but I will go in a most basic orthodox approach. This is 5, okay? I know 5. My radius is 5. My distance from origin is 5. But where? This is pi over 4. This says 5 pi over 7. That is how much? 5 pi over 7. If it is 10 pi over 7, sorry. If it is 7 pi over 7, then we are going here. It's 5 pi over 7. So it's pi minus 2 pi over 7. That's what gets me 5 pi over 7. So pi minus 2 pi over 7. And then so this is my 2 pi over 7, this angle here to here, and this angle is 5 pi over 7. That is how it becomes 7 pi over 7, 1 pi. And then my radius is 5, so we are talking about this point. So this is 5. What we have to find out is Cartesian coordinate. So we know that, okay, since I am falling in the second quadrant, my x coordinate will be negative. Let's find out the absolute value and then put a negative to it. And this is y. Now, if you look at this is my theta, this is my 2 pi over 7. Okay? I'll ignore the negative part right now. I'll just look at this right angle triangle with this being 2 pi over 7. So this length, absolute length is what? So this is y, this is x. Here to here is x. So x over 5 is equal to cos 2 pi over 7. And y over 5 is sine 2 pi over 7. Now this 2 pi over 7, if I just convert to degree, just to get a rounded value like what Praneeth did. If you guys have a calculator, you can always find out value of sine 2 pi over 7 or cos 2 pi over 7. So this is 2 pi over 7, 2 into 180 over 7.
So this is 360 over 7. So we're talking about 7, 5 and 30, 5, 1. So 51.
So it's 51 point some degree, okay? Which is closer to 45 degrees. So if I'm talking about sine 45 degrees, I'm talking sine 45 and cos 45 both are 1 by root 2. This is 1 over 1.414. So if I'm talking about sine 45 degrees, this is more than this is more than this. So it will be 1 over 4.14 is like 0.7. I will make it 0.8 just for the sake of simplicity, okay? So y equals 0.8 into 5, which is close to 4. You might be wrong, right? Okay, I'm just rounding it. If I'm talking about cost also is 1.414, but cost value when increases moves towards 90, decreases actually. So this will be less than this. It will be probably, I'll go for 0.6 kind of thing. So x over 5 will be equal to 0.6, or x will be equal to 6 into 0.6 into 5 equals 3. So closer to 3, this will be closer to 4. So if you use calculator, it will tell you the exact value. I have just done the rounding just to validate if this value is looking okay or not. Yeah. So for you guys, since you will have the luxury of using calculator in the examination hall, this is where you will use the calculator. Because you certainly don't want to waste your energy and time for finding something that is given to you, right? But the concept, the approach part is where you'll put your brain. Correct? Did I explain it okay or I did not? Now the silver bullet that I was talking about. Be it polar coordinate, be it circle theorem. Both are same, right? Circle theorem also talks about the same thing. When you convert that to unit circle theorem, you talk about radius being 1. So net here, when you have the x and y coordinates, right? Any point on this circle, the x and y coordinates are r cos theta and r sin theta. As you can see here, this x coordinate, x over r is cos theta. So x equal to r cos theta. X coordinate is r cos theta. Y coordinate is y over r is sin theta. So y is r sin theta. So if you guys like remembering things or memorizing things where you don't want to decode this on the fly and save 30 seconds of your time, as long as you remember this, that also works. So if you are given the x and y coordinates, or you are given the polar coordinates r and theta, you will just convert this, okay. So my x coordinate will be r cos theta, the base part, and r sin theta. If you apply that straight, you don't have to do any calculation. You put the angle, it's 5 pi over 7, put that angle straight. You don't have to do negative positive thing, okay. Here after we got x value, we saw this is this quadrant, so x will be equal to minus 3 because this is the second quadrant. Y value is positive, so y will be plus 4. So minus 3 and plus 4. But if you're just applying the theta, you don't even have to get into that plus minus thing because calculator tells you everything. Say sine pi over 4 versus sine 5 pi over 4, it calculates for you. It tells you the sign, whether it's positive or negative. Yeah. But are you guys okay conceptually or? So the rule of thumb here is this. Geometry is something, be it geometry, be it anything to do with trigonometry or algebra is more of a calculation, but geometry and trigonometry is more to do with the visual side of it. Any geometry or trigonometry problem that you're dealing with, my most important recommendation to you guys would be, even if your drawing skills are as pathetic as mine, still draw. Okay? There are two things that starts with V, which I am very, very poor at. Okay? One is drawing and second is dancing. I'm the last person to dance even in any public gathering, because I know if I dance, everybody will stop dancing. They'll look at me. So is the case with my drawing skills also. I'm saying, no worries. What kind of problem you're dealing with? If you see that okay, there's something to do with geometry or trigonometry, collect the information, read the question, and then just try drawing a sketch. Try visualizing this. Let's say you're trying to solve a problem with geometry. You are given a long story. Get the information from that. Try drawing it. See what it is saying, and then that will give you a very clear view of how you can approach it actually. Is it making sense? No? You guys are very, very shy. Don't be. Tanvi, Vishal, Pranit, okay? Davik, are you clear with that? Okay. Now I'll give you guys one problem, and I don't want you to solve it. I just want to scare you guys before you go. So there is a word problem, okay? This says, just hear me out, okay? Jessica states that she will move the point horizontally 1 to the right and then rotate 5 pi over 6 counterclockwise to quadrant 2. So this is a word problem, okay? It says Jessica states that she will move the point horizontally 1 to the right, and then rotate 5 pi over 6. I got a little emotional, completed a pi, but yeah, 5 pi over 6. Counterclockwise. So not clockwise, counterclockwise 5 pi over 6. So this is the angle that she has made, this one. Okay. To quadrant 2. So basically, if you look at this, right, this is in quadrant 2. Jamil states that he will move the point vertically up 1 and then rotate 5 pi over 6. Then from here rotate 5 pi over 6. 5 pi over 6 will be somewhere here. No, not here. 5 pi over 6, little less than a pi. Somewhere here. Counterclockwise to quadrant 3. See, it has come to quadrant 3. Who will graph the polar coordinates? Who will graph the polar coordinates correctly? So basically, you are given that Jessica says she will move the point horizontally 1 to the right and then rotate 5 pi over 6 counterclockwise to quadrant 2. Jamil states that he will move the point vertically up and then rotate 5 pi over 6. Now the question is, who will graph the polar coordinates correctly? What is the basic premise? See, this was a word problem. Probably I got you guys a little confused. If you look at the basic premise of polar coordinate, what it says, how much against the positive x-axis. Jessica said, I am moving this much to the right and then rotate. See, how much? So she's going to the right and then rotate, meaning she's first picking that x-axis, then rotating. This guy says, I'll move up and then rotate. So this is not about the y-axis. It always starts with x-axis and then how much you have rotated. If it goes here, then he's talking about this angle. So from a concept point of view, this might be a very theoretical question. You have to just look at how do you relate that with polar coordinates. Polar coordinates say, okay, positive x-axis, how much you have rotated. Here it was like a 2 paragraph, just to get you guys confused. X-axis, how much rotation? That's what it is. So Jessica rotated the right way. She is right. Jamil said, I'm starting from here and rotating by this much. This is not against the X-axis. So you have to do extra calculation, and that is not how polar coordinates are visualized. So that is where you'll have to make those judgments based on the basic concept. Okay, I mean it was more to do with the basic concept of polar coordinates rather than anything else. We have to just relate. Okay, polar coordinates, many x-axis, positive x-axis, then rotate. That's what it is. I know towards the end we had a very stupid question, but unfortunately you might come across a stupid question in your exam also. So as long as you are prepared both ways, you're good. Are you guys okay with whatever we discussed today, or I got you guys more confused than letting you learn something? All good? With that being said, I'll let you guys go. Enjoy the rest of your evening. Talk to you guys on weekend.
Bye. Thank you.
Bye bye.